Hi, I'm Eugene and this is our dev team.
I'm Alex.
I'm Steve.
I'm Hannah.
And welcome to Rogue Survivor, a real-time multiplayer roguelike game. Roguelike games describe a game where players traverse dungeons and fight monsters while collecting coins to purchase upgrades and pursue the next level. We chose this popular genre because of the low skill barrier to entry and high replayability, demonstrated by the popularity of Enter the Gungeon, another roguelike title. The game was developed from Rogalik, a simple roguelike game using a Pygame framework. Our primary interest was in extending beyond modern roguelike games that use a mouse and keyboard or a game controller by introducing a more interactive and social gaming experience. We accomplished this by replacing the mouse and keyboard with a novel controller design for movement, an LED wand for attacks and speech commands for player interaction, while adding a multiplayer aspect in lieu of the traditional single-player roguelike games. Although the moveset is quite simple, we believe mastering the controls and the game variability are the key aspects to a fun gaming experience for Rogue Survivor. In addition, the elements we added to the game were influenced by the trending Internet of Things technology that permeates many aspects of our life, including smartphones, wearable health devices, and smart homes. As a result, the project utilizes many sensors to interact with the outside world, and our multiplayer capabilities reflect the growing network of IoT devices. The following table displays the work distribution of this project. So as you can see, we all worked on the game design. Alex worked on the localization, and I was a secondary for this. I worked on the gestures, and Hannah was a secondary. Hannah worked on the speech recognition, and Alex was a secondary for it. And Steve worked on the communication, and we all assisted as secondaries for this part of the game. Work was distributed such that each feature has a primary and secondary members, as you can see. Primary members were responsible for the development of the feature, while secondary members were responsible for providing feedback suggestions and support the primary members. Splitting up work into this structure enabled the parallel development of game components.
Hi, I'm Eugene and we've met before, but I'll be discussing player movement. We accomplished player movement by creating a handheld, intuitive, and wireless controller to introduce a novel way to play a roguelike game. The controller includes a ESP-32, a smartphone IMU, and a battery pack in this case. Although our electronics are not complicated, the controller design and fabrication process incorporated top-end CNC machining and laser engraving, resulting in a very clean, aesthetic controller. To move their character, the players will tilt the avatar in the desired direction to move their character, shown in the following video. The detection relies on the accelerometer readings to determine the pitch and roll of the IMU. We determine pitch using the x-axis accelerometer readings and the roll using the y-axis accelerometer readings. Finding ideal pitch and roll values required playtesting by peer groups to determine what felt natural for players. For added robustness, the player is limited to only 8 directions, corresponding to a number 1 through 8, reflected in the following diagram. Most importantly, the controller was designed with user-friendliness in mind. Aluminum was used to keep the controller light, but also aesthetic with its shininess. To add to its aesthetic, we have isolated and hidden all the electronics from the player in the controller's base. We also constrained the base to a small footprint, making the controller something you can travel with. For ease of grip, we chose a cylindrical stick. A laser machine from controller to laser was used to engrave an arrow indicating the player's orientation and the player number for ease of use.
Hi, I'm Alex. I will be discussing player attacks. Our players will hold a wand embedded with a LED pump light in front of the webcam of the player's PC to control the character's attacks. By holding a wand in a specific area of the webcam field relative to the angle from the origin, the players can orientate the weapons at 15 degrees increments around the characters. In addition, if the LED is not fully exposed to the webcam, the weapons will not attack. The LED's localizations was accomplished using the image processing powers of the OpenCV library to detect the 3 key parameters. And first of it is object color detections, which used it to locate the green LED, and object area detections, which will be used to detect whether the LED is fully exposed in the webcam's field of vision as a threshold of triggering a player's attack, and also object controls detection, which will be used to detect the player's attacking angles. And lastly, to ensure a player-friendly experiences, we have made the LED compact to minimize the space required to play and make the wand easier to grab.
Hi, I'm Hannah. I will be discussing object interactions. We leveraged advanced speech recognition technology powered by Google to handle object interactions, which include picking up and dropping an item. This feature is activated through an innovatively designed Bluetooth-enabled button embedded within the player's wand. To initiate an interaction, the player presses the Bluetooth macro pad button on the wand, then speaks to either pick up or drop the object. An external microphone is employed to accurately capture the player's speech commands to enrich the interactive experience while maintaining the functional integrity of the gameplay environment. Threading was needed to maintain real-time responsiveness to player commands by offloading the speech recognition to separate threads, ensuring the main game loop was unaffected. Building dictionaries to relate similar words was another essential step to enhance recognition accuracy. Playtesting allowed us to enhance this dictionary by discovering new words that could be mistaken for a command. For example, we found that in one instance, trumpet got recognized for the drop it command. Through high-quality audio input, threading, and optimized dictionaries, we developed a reliable and user-friendly speech recognition system that enhances player interaction and immersion.
Hi, I'm Steve. For log survival, we want to create a low latency and reliable connection to provide a real-time multiplayer experience where players fight in the same dungeon. We accomplish this through screen mirroring by utilizing socket programming. Instead of transmitting game objects, we transmit the game screen from the server to the client. In this setup, the client passes the raw data and sends their inputs to the server. Then the server is responsible for making game updates based on the client's input and sending the updates screen to the client. In addition, before players start the game and enter the dungeon, they will be introduced with a server join and creation lobby to begin their multiplayer journey. Here the server will pop up a lobby screen that displays the IP address, and the client enters that IP address will join the game.
To improve players' experiences, we conduct peer testing. We had our partner group fill in a Google form after the gameplay to collect their feedback and suggestions to elevate the performance of our game. Based on their responses, we made the following changes. Algorithm optimizations for object detection sensitivity. Adjusted tilting level to lower the amounts of tilt. Update the workbench for additional variables found during the peer testing. We have also implemented game balance in response to their feedbacks. Those balance include players will be 50% slow, and the player's health will be 100% higher, and the enemies will be 500% slower, and the enemy health will be 100% lower, and the enemy rate of fire will be 300% slower.
To ease players into the game, we constructed a tutorial in the first room of the dungeon. The Rogue Master, who was inspired by the Dungeon Master from the game Dungeons & Dragons, appears in the graphic user interface to instruct players on how to play the game. The players are prompted on how to use the controllers one at a time. They can cast pink to go next, meaning pressing the pink button, or if they missed a step, they also have the option of casting blue to go back to the previous message. Custom colored keycaps were handmade out of a durable polyurethane resin material and incorporated into the wand design to offer players a fun and user-friendly experience. Once the players learn how to control player movement and pick up a weapon, one monster spawns. The players can then practice their aim using the wand. The monster is programmed to not inflict any damage to the player's health during the tutorial stage. Once the players are comfortable, they can proceed to the next room where the fun begins.
With all the amazing features for our project, we have lots of plans to improve and expand the game. First, the frame rate is about 10 FPS now, and we are hoping to increase it for a smoother gameplay. In addition, our game only supports 2 players, so we are also planning to increase it to 4. Besides that, we are aiming to introduce more enemy types as well as more weapons to the game.
From these past 20 weeks, our team has learned a lot about game development in a fast-paced, highly collaborative environment. We are immensely proud of our game, Rogue Survivor, which pushed the boundaries of the original traditional roguelike base game by integrating advanced technologies to create a more immersive and spatial experience. We hope that the technologies and methods we implemented can inspire future game development, where user-friendliness and interactivity are paramount. In the end, we would like players to find joy in the game we created. Thank you to all those who supported this development and enjoyed Rogue Survivor.
Okay, that's empty. With all the amazing future, not future. Okay, cut that part.
We leveraged